Hello all. In this video, I'll explain about graphical solution of linear inequalities in two variables. You had seen linear inequalities in one variable like x is less than 2. So in such cases, we'll be graphically representing them, that is on a number line. Suppose you have 0, 1, 2, 3 and here minus 1, minus 2, less than 2, x is less than 2, the solution set is nothing but minus infinity comma 2. So then we'll start from here, then we will shade this region, and this entire region represents the solution of the linear inequality in one variable, that is x is less than 2. Suppose if you have linear inequalities in two variables like 2x plus 3y is greater than or equal to 5 or x plus y is less than 2. These are called as linear inequalities in two variables. Now when there are two variables, then how exactly you will find out the solutions for the given linear inequality. So this is one linear inequality in two variables. So usual method is like just putting the values for x and y and checking whether it satisfies the inequality or not. There are infinite number of solutions. So to get exactly those infinite number of solutions, it is trial and error method, takes a long time. So instead of that, we can do in a some other way, that is called as a graphical solution. In using the graphical method, we can represent the solution region. It is not single solution we are getting the entire region in a plane. That is called as graphical solution for the linear inequalities. So you already know that ax plus by, this expression or this polynomial always represents, this thing always represents a straight line. It's a straight line. So when you are finding the graphical solution for linear inequalities in two variables, definitely you will obtain a straight line. Then based on the orientation of that straight line, we will be obtaining the solution. Let's see how to do that. Now say for example, whenever you have any straight line, there are two possibilities, like two types in the straight line. One is vertical line, one is non-vertical line. Non-vertical, horizontal is also included in the non-vertical line. When you have a vertical line, when this vertical line is drawn on a plane, it divides the plane into two parts. One is left half plane, one is right half plane. So this portion is called as the right half plane and this portion is called as left half plane. So if you have a non-vertical line, in the case of a non-vertical line, it divides the entire plane into two regions. One is upper half plane, the region above the line is called as upper half plane, and the region below the line is called as, this region is called as lower half plane. So for a vertical line, you have two segregations of the plane. One is left half plane and one is right half plane. For the non-vertical line, the entire plane gets divided into two parts, upper half plane and lower half plane. This we have to keep in mind when we are finding the solution of a linear inequality graphically. Now when you consider a horizontal line, that also comes under non-vertical line. It divides the entire plane into two parts. One is upper half plane, one is lower half plane. So let us go with one example. Let's solve one problem. Solve the inequality 3x plus 2y greater than 6 graphically. So what I do here is, first always you have to write the corresponding equation associated with this inequality, because you know that 3x plus ax plus by, that always represents a straight line. Ax plus by equal to c or ax plus by plus c equal to 0, that always represents a straight line. So to get that straight line, we have to write its corresponding equation 3x plus 2y equal to 6, because we should know whether it is a vertical line, non-vertical line, how it divides the plane. For that we need a straight line first. So the straight line is obtained by writing the corresponding equation associated with the given inequality, that's 3x plus 2y equal to 6. So after that, next step is you have to draw that straight line associated with this equality. So that is done using plotting the points x, y. When x is 0, substitute x equal to 0 here, 2y is equal to 6, y is equal to 3. When y is 0, 3x equal to 6, x is equal to 2. Now you have to plot these points, 0, 3. 0, 3 comes here and 2, 0 comes here. Now you have to join these 2 points. To join those 2 points, there are like, here you have to see the inequality, type of inequality. Is it a strict inequality or is it a slack inequality? You know that strict inequalities are these. Slack inequalities are greater than or equal to, less than or equal to. So when you have that equality sign, it tells you that the points on the line are solutions of that given inequality. But now, as it is strict inequality, points on the line, whatever the points you have on the line, they are not solutions of the inequality. Hence, you have to join these 2 points by dotted line. This is a dotted line. This is not a continuous line. There are some breaks. So that means the points which come on the line are not solutions of this inequality. So you can substitute here 0, 3. If you put 0, 2 into 3, 6 comes. 6 is not greater than 6. Suppose if you have greater than or equal to, then it satisfies. That's why when you have a slack inequality, it is a continuous dark line. When you have strict inequality, it is a discontinuous line, in the sense it is dotted line. So that is done. That part is done now. Now let us, this is a non-vertical line. This is clearly non-vertical line. Now this non-vertical line divides the entire plane into 2 parts. One is the part region above the curve is upper half plane, and the region below the curve is lower half plane. Now you have to check whether the points in the upper half plane are they solutions, or points in the lower half plane are they solutions of this inequality. So for that sake, you can choose any point. It is not necessary that you have to choose 0, 0 only all the time. You can choose any point, but it should not be on the line. That is the basic thing you have to keep in mind. Because on the line, already we have verified they are not the solutions of this inequality. Now we are left out with the points above the line and points below the line. You take any point which comes above the line or any point which comes below the line. Here 0, 0 is valid, even if you take, no problem. 0, 0 comes below the line. Or else if you want to take 1, 1, 1, 1 also comes below the line. Here I have taken 1, 1. So take 1, 1 and substitute in the inequality. First you have to see where this 1, 1 lies. 1, 1 lies in the lower half plane. Substitute in the inequality, that is 3 into 1 plus 2 into 1 is equal to 3 plus 2 is 5 greater than 6. Is it true? It is false. 5 is not greater than 6. This is false. Therefore, this 1, 1, whatever you have chosen, that lies in the lower half plane, for which the inequality is false. Hence, the lower half plane, entire lower half plane could not be the solution of this linear inequality. That is because even if you take any one point, for every point it should satisfy the inequality. But it is not satisfying for 1, 1. If it is not satisfying for 1, 1, you can stop there. You can say the region opposite to the lower half plane, that is upper half plane, is the solution region, and you have to shade this entire region. So that solves the inequality. So you take any point in the upper, like 2, 1. So 2, 1 comes in the upper half plane. You can substitute here 3 into 2 plus 2 into 1. 3 to the 6 plus 2, 8. 8 is greater than 6. True. Yes. For any point, if you consider in the upper half plane, it becomes a solution of this linear inequality. Hence, the solution set is upper half plane. So that is how we solve a linear inequality in 2 variables. Now, to solve system of linear inequalities, that's one more. Solution of system of linear inequalities in 2 variables. System of linear inequalities means more than one linear inequality is given to you. So when you have more than one linear inequality, you will be having more than one lines in the given system. So you have to find their common region. First you find out individual solution region. Then you have to find out where they all come together. So that particular region becomes the common resolution region. That is the solution of the given system. So now look at this problem. Solve x plus 2y less than or equal to 10, x plus y greater than or equal to 1, x minus y less than or equal to 0, x comma y greater than or equal to 0. This is very clear now. X comma y greater than or equal to 0 means you know that equation of x-axis is y equal to 0 and equation of x-axis is y equal to 0 and equation of y-axis is x is equal to 0. So x greater than or equal to 0 means all positive values of x. Y greater than or equal to 0 means all positive values of y. That comes in the first quadrant. So these two inequalities, no need to solve separately. You should remember x comma y greater than or equal to 0 always comes in the first quadrant. Let us see the remaining three inequalities one by one. So you have to write the corresponding equation. Let me write that. X plus 2y equal to 10, x plus y equal to 1, and x minus y equal to 0. These are the corresponding equations. So let us draw the corresponding lines now. So when x is 0, y equal to 5, y is 0, x equal to 10. Okay, x plus y equal to 1. When x is 0, y equal to 1, y is 0, x equal to 1. Next, x minus y equal to 0 means that gives you x equal to y. It's a line passing through the origin. So when you put x equal to 0, y also comes 0. Y 1 means x is also. Both are equal. So when you put once again 0, 0, 0, 0, with 1 point you can't draw a straight line. There are infinite lines passing through that point. So you have to go with some other value of x other than 0. So that gives you another point 1, 1. Let us plot all these points in the graph. So let's do that now. So first x plus 2y 0, 5. 0, 5 comes here. This is the point 0, 5. And another point is 10, 0. This is the point 10, 0. Now you have to join these 2 points by dark line. That is because you have the slack inequality. Slack inequality means the points on the line are also solutions. So let me join these 2 points by slack line. Sorry, not this way. Yes, this is that line. So let me name the line so that there won't be any confusion. The name of this line is x plus 2y is equal to 10. Let us go to the second 0, 1 and 1, 0. 0, 1 and 1, 0 comes here. So let us join these 2 points by again dark line, not dotted line, because they are all slack inequalities. So you should be careful that should pass through these 2 points exactly. Yes, this is that line. So this line is named as x plus y is equal to 1. Next, x equal to y means 0, 0. This is that point 0, 0 and 1, 1. So 1, 1. It is a line passing through the origin. So you have that line as passing through the origin. So this is the line. So it's given by x equal to y or x minus y equal to 0. Now these are the 3 individual lines. Let us find out the individual solution region for each line. So consider the first line. So it is a non-vertical line. It divides the plane into 2 parts. One is lower half plane and one is upper half plane. You choose any point from the lower half plane or upper half plane. It is up to you. Let me choose 0, 0. If it is available, you always go with the 0, 0 because it's easier to simplify here. 0 plus 2 into 0, which is equal to 0, less than or equal to 10. Yes, the inequality is true. So 0, 0, this is for this line I am doing. It lies in the lower half plane and for which the inequality also comes as true. Hence the solution region of this line is lower half plane. Let us just mark it using 3 or 4 arrows enough because we want the common region, not the individual region here. Okay, x plus y greater than or equal to 1. Let's see x plus y, this line. So again this line you can make use of 0, 0, no problem because 0, 0 lies below the line. Again it's a non-vertical line, lower half plane and upper half plane. 0, 0 is in the lower half plane. Let's substitute 0 plus 0 greater than or equal to 1. 0 greater than or equal to 1. Is it true? This is false. 0 is not greater than 1. Hence 0, 0 is in the lower half plane, but for which the inequality is false. Hence the lower half plane can't be the solution region. The solution region is upper half plane. So let us go with the third one. For the third one, most of us do mistake here by choosing 0, 0. Now you need not choose 0, 0 because it's a point on the line. We know that point on the line already is solution of this linear inequality. That's why we have drawn the line using the dark line. So hence it is not the required. Now you choose any point. It's a non-vertical line. There is upper half plane, there is lower half plane. Choose any point which is either in the upper half plane or lower half plane. I will choose 1, 2. So 1, 2 is in the upper half plane with respect to this line. Let's substitute 1 minus 2 less than or equal to 0. 1 minus 2 how much? Minus 1 less than or equal to 0. Yes, this is true. Negative number is lesser than 0. It is true. Therefore, the solution region is the upper half plane. For this line, the solution region is upper half plane. For this line, the solution region is upper half plane. And for this line, it is lower half plane. Now, where all these lines will meet? So, this is lower, downwards, and this is upper. This is upper, and this is also upper, okay, and it should be in the first quadrant as per these two inequalities. So the common region comes out to be this full region where all the three lines solution regions will meet. Hence this region becomes the common solution region of the inequality. You can check with that. You can choose any point within this region, like 1 comma 2. If you choose 1 comma 2, it will satisfy all the inequalities. You check with that. 1 comma 2. 1 plus 2 into 2. 2 2 is the 4 plus 1, 5. 5 less than or equal to 10. Yes, true. Next, 1 comma 2. 1 plus 2 greater than or equal to 1. 3 greater than or equal to 1. Yes, true. 1 minus 2 is equal to minus 1, which is less than or equal to 0. That is also true. Hence, all the three inequalities. Any other point also you can choose from this common region. That gives you the solution of the this system of linear inequalities. So, when you are solving system of linear inequalities, you are finding the common region. Hence, individual shading is not required. This common shade region has to be shaded, has to be dark shaded to convey the message that this point, these points will give you the solution of the entire system of equations. I hope you understood the concept. Thank you for watching.